if I want to write this out longhand, what is a to the fourth? What am I doing with that? So a times itself 4 times. So I have 4 a's. A times a times a times a. What about a squared? What's that? 2 a's, yeah. Multiplied together. So if I look at what that represents overall, that's a to what power? A to the 6th. Because exponents mean repeated multiplication. What I'm going to be doing with this is saying, well, I did it 4 times here. I did it 2 more times here. That's a total of 6. So what's the operation with 4 and 2 that land me at 6? Addition. So this is really the same as a to the 4 plus 2. And that's why this rule works. Now the rule specifically,
Wait, is that the answer?
yeah. If I simplify a to the 4th times a squared, that's going to give me an answer of a to the 6th.
You can only simplify it like that.
And here is the catch, though. The bases have to be the same.
Yeah.
Same bases. If the bases are different, you can't combine them this way. You just have to leave them. What's up? Somebody else had asked to go.
Me?
Yes, go. So as long as the bases are the same, you can do that. If they're not, you can't. So here's the rule. X to the A times X to the B is X to the A plus B. That would be the rule we're going to be using. Now note, that's times. It does not apply to addition. For example, I can't do y squared plus y to the 3rd does not equal y to the 5th. That's a very common mistake that students make. Because this is y times y plus y times y times y. That's not 5 y's all multiplied together. That's 2 y's added to 3 y's. Can't do that. It only works for multiplication. It doesn't work for addition. So this rule has to do with when I multiply the same base. It also applies to x squared plus y to the 4th is not xy to the 6th. The bases have to be the same. Or I'm sorry, let's make that times. If the bases are not the same, doesn't work. Shoot. That's not really important right now.
Why is y squared plus y 3 not equal to y 5?
Because it's addition.
Oh, okay.
Yeah, addition doesn't work, and if the bases are different, it doesn't work.
Okay.
It's only if they're the same can you get away with it. What's what?
What would be the final answer to the letters?
To this one?
No, the one on the left.
This one? Over here?
Yeah, right.
Whatever that sum is will be the final answer. Let's do one more example then, kind of like this up here. You might see, let's do 2 to the 3rd times 2 squared. That's going to be, if I said simplify that, that's 2 to the 5th. And then I can quickly think, okay, 2 to the 5th is going to be 2 times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32.
Wow, you're good.
Well, the advantage of 2 to a power is you can usually count that out there because you're just doubling. The bigger numbers to a power tend to be a lot harder. 32? 2 times 2 times 2 times 2 times 2. You'll also see a lot of these in the context of variables. So something like this. This is one of the ones the book uses. Y squared times y to the negative 1st. Now there's a temptation to want to shift stuff up and down. Don't do that at first. Save that for a little bit later. If I go down all my y's and add up my exponents, what am I going to add right here? Positive 1? Close. Remember, if there's no exponent, there's a pretend 1 here.
Oh, 0.
So it got colder. 2 plus 1 plus a negative 1 would be y squared. Yeah. If the bases are the same and you're multiplying the numbers together, then you just add the exponents up, and that gives you the final exponent. Let's take a look at another one of these. Here's kind of an easier one. How about, I like this guy. M to the 6th, n to the negative 2, m squared. And then I'll stop this tape and start a fresh one. Do I have any common bases that can be combined?
Yeah.
I got these m's. So that's going to be m to the 6 plus 2. And I can't do anything with the n because the base is different. So I just leave it there. And so this then becomes m to the 8, n to the negative 2. Somebody, what's my final answer? Right, this guy has to come into the denominator because it's negative.
Wait, how'd you get 6 plus 2? I just did 6.
How did I get the 6 plus 2? Same base, same base. So add the exponents together. 6 plus 2.
Oh. Okay, yeah, I get it. Okay. And then after that, like, you added 6 plus 2 and then you subtracted with negative 2.
I don't subtract the 2 though because it's a different base.
Oh.
So the m's becomes m to the 8th. This remains n to the negative 2, but negative exponent means I got to move it down. There it goes.
Oh.
All right, sweet.
When you put that in the